Assalamu alaikum, I'm back with application-security.io owasp top 10 for API, and today we are going to do insufficient logging and monitoring lab. So let's start this lab and see what is present in this lab. So there is a website named as CodeDoc. It is a cloud-based code repository and issue tracking platform like GitHub, and it has an API that we can integrate in our application projects, and we can interact with this. And this CodeDoc is actually the server version control system. Okay, so Alice thought that he must use this CodeDoc website for his applications. He have created a sign up over here, and then he had login credentials with him. So when he logs in, he can see that in his account he will get a private token. So whatever application he is going to make, he has to add that private token in that application to use this API in his project. So let's move further. So before moving further, let's copy this and assume that let's see the web server logs, application logs of CodeDoc's website. Okay, let's see application log. These are the application logs. On this time this activity happened, on this time this activity happened. Okay, so these are the application log of CodeDoc website. Let's move further. So as an Alice who made an account on this website and have an access to the private token, he tried the curl command to this website with the private token or API he received from CodeDoc. Okay, and when he pressed enter, you can see that there is no logging related to who accessed this thing. Okay, a log statement is added like returning cached instance of single bean cache controller, but it is not mentioned in the log that it was Alice and on what time he did that and from which IP he accessed this CodeDoc's API. So although the lack of event logging for Alice API request may appear to be a significant security risk, let's assume a scenario. It does not appear to be a significant security risk. Let's assume a scenario where Alice API token got leaked, stolen, or misused by an attacker. In such instances, the lack of traceability to reconstruct an attacker's action may prevent CodeDoc's security and incident response team to successfully identify a potential security breach and further carry out the root cause analysis of what has happened. So let's move further. To further analyze the issue, let's analyze this code. So CodeDoc developer implemented the get projects method, which is used for retrieving the list of projects, right? First, it extracts the private token header to validate that are you a valid user who had an account on CodeDoc website, or you are just a random person trying to access the API. If the token is valid, the method returns the list of the projects related to your API key. However, notice that no logging is done over here in this API endpoint, so the developer cannot track any suspicious activity related to this endpoint. Let's move further. So how this issue has been mitigated? In order to effectively mitigate against insufficient logging and monitoring issues, developers must follow the logging best practices. Ensure all login access control feature and server-side input validation feature can be logged with sufficient user context. Okay, the user context is very necessary, that who tried to log in into which account at what time, from which IP, all of the fingerprints should be in the log file. Ensure that logs are generated in a format that can be easily consumed by centralized log management. You should not go for some custom log creation mechanism. There are log servers which we manage centrally to consume the log of different devices, different web applications, different servers. So it should be like in some standard format. Ensure sensitive actions have an audit trail with integrity controls to prevent tampering or deletion, such as append-only databases or similar. There are some databases in which are only read-only. So if someone is adding some content to that must also be logged in your log file. Establish effective monitoring and alerting such that suspicious activities are detected and are responded in a timely fashion. So time is also an important thing, that at what time this activity has happened. So in this code, this logging interceptor has been implemented by the developer. In order to implement adequate logging, the developer leveraged the capability of JavaScript Spring's interceptors. This is the built-in feature. You do not have to write some pretty fancy code to implement the logging in your code. So let's move further. The logging interceptor is called on every HTTP request. Whenever this API is requested, there should be a logging performed. First, it extracts some valuable data from the request, such as timestamp, HTTP method, URL, and IP address of the client, and it is logging in a very professional manner. And this statement logger.debug would add the timestamp, the method access, the URI, and the IP address, which is considered as the fingerprint. All of these things would be logged in a file. Let's move further. Now again try to curl the request to this API endpoint, and let's see if there is some logging performed. Now you can see that the request method, API endpoint, IP address, and the time, all of the 4 things are logged in this log file. Now if something suspicious happens as such DDoS attack, the developer will be able to identify the source of attack by the IP address retrieved from logs and react accordingly. Okay, so this is all from the insufficient logging and monitoring. We'll meet in the next video. Till then, Allah Hafiz, Jazakumullahu Khair.